Hypothalamus Artificial Intelligence, HI, is a knowledge-intensive company in advanced and complex mathematical modeling. Its main research focuses on the integration of traditional artificial intelligence, mainly supported by artificial neural nets, ANN, and the machine learning algorithms, based on support vector machines, SVM, with the large-scale mathematical programming principles. This is aimed at producing artificial brains, that is digital transformation driven by autonomous and intelligent algorithms in real time, in accordance with the era of Industry 4.0. The guarantee of our growth, and the quality of the knowledge we produce, is supported by our areas of research, technological development and innovation. These are artificial brains, large-scale parallel optimization algorithms, and optex, the artificial intelligence that make artificial intelligences. As a result, our intellectual property helps produce highly complex mathematical models for end users. HI was created in 2021 and began formal operations at the end of 2022. Its founder and chief scientific officer is Ang. Jesus Velasquez Bermudez, Ph.D., who at the age of 21 made for Federal in Colombia, his first professional job as a mathematical modeler. At the age of 22 he obtained his master's degree, working on a stochastic optimization model, and in 1978 he created, in Caracas, his first company, where he was the leader of mathematical modeling. In 1990 he created Decisionware Ultima, in Colombia. HI is a spin-off company of DW, conceived during the COVID-19 pandemic. Ang Velasquez Bermudez's professional life is divided into three main stages: growth until 1990, maturation until 2015, and acceleration since 2016. He obtained his Ph.D. in 2006, at the National University of Colombia, Campus Medellín. Artificial brains. This is the biggest challenge taken on by HI. It's the result of its 50 years of work in highly complex mathematical modeling. Framework. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. This evolution may be summarized as the shift from artificial intelligence to augmented artificial intelligence. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical models that exchange autonomously information between them, working online, using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by optex, the HI's cognitive robot, using the models that traditionally make up a decision support system. Starting from the perceptron, the first artificial neuron created, the knowledge of neuronal modeling has evolved, currently having multiple types of artificial neural nets. This new type of neuron will be called mathematical artificial neuron. Its name was derived from the fact that the neuron is built, based on mathematical models that represent a system, and that it does contains logical or intuitive elements. Two mathematical artificial neurons communicate with each other, forming a network of mathematical artificial neurons. Communication occurs in two directions between the two neurons. The greatest advantage of mathematical artificial neurons is that they represent clearly defined objects within a system, that communicate with each other through fully known mathematical laws, and that they comply with laws with transitivity and divisibility laws, in such a way that a system can be atomized, to the level of knowledge that the scientist on duty has. To connect multiple algorithms, today may be hundreds of thousands, but soon, of course trillions, it is necessary to develop a universal mathematical language for algorithms. The principles of this language, of mathematical origin, be based on. So, the artificial hypothalamus, a part of the artificial brain, is the algorithm that control the workflow of the models of the decision support system. It includes the constraints that guarantees that the system is in the optimal path. This is based on the duality theory. Starting in 1978, the HY's intellectual property, HY-IP, began to accumulate knowledge about large-scale parallel optimization algorithms to accelerate the solution of highly complex mathematical problems. At the time, the founder of HY was involved in a Venezuelan company, PDC Ingeniería, which invested $500,000 in a Modcomp Classic computer with 1 megabyte of RAM, some cache memory, and 10 megabytes of hard drive. To be able to implement large models, in such a small computational environment, it was necessary to learn methodologies such as Bender's partition, and Lagrangian relaxation. Not to do parallel computing, but to be able to solve real problems in such a small memory. HY-IP appropriated the knowledge of the duality theory as the basis for solving problems based on their atomization. It was like a company in Silicon Valley, but in Caracas. Their economic future was not guaranteed. These algorithms accelerate large-scale math problem solving by partitioning and decomposition of complex systems, atomization, and the integration of physical models of differential equations with large measurement systems. Parallel optimization algorithms, to accelerate the solution of large-scale mathematical problems, by partitioning and decomposing complex systems, that are part of the HY-IP. Multi-state Kalman filter, MSKF. Generalized dual dynamic programming, GDDP. Nonlinear dual dynamic programming, NLDDP. Primal dual surrogate algorithm, PDS, and multi-Bender's decomposition, MBD. They are included as standard methodologies managed by OpTex, Optimization Expert System. OpTex is an expert system focused on the design, implementation, startup, and maintenance of high-complexity mathematical programming. Expert system in the sense of artificial intelligence. OpTex was born from a paradigm change in the traditional form to make mathematical models. The traditional process implies that making a model implies making programs, which becomes the most expensive activity of the whole process. The paradigm shift was very successful in 1991, when OpTex was born as an optimization technology of decision-ware limited, DW. The new paradigm consisted of parameterizing the model into a relational information system for optimization, and creating an intelligent tool that, based on the contents of the database, generated all the computer programs for the model to work smoothly. The level of abstraction of the information system data model was such that in practice, all DW mathematical models were performed using OpTex, Optimization Expert System. Over time, the database became a repository of models, which can be managed by simply clicking, allowing to dynamically join, split, or adjust the models, to extent that new models, or new versions of existing ones, require, making mathematical models like a Lego model. Despite OpTex technical success, its commercial success as a commercial optimization technology was not a success. But the facts show that many AI researchers are trying to solve the problem of making automatic programs without errors, a test already passed by HY in the real world. OpTex is the tool that emerged from Praxis, that organizes all concepts of artificial brains. This is fortunate for HY, which gives it a many-year head start on the road to creating perfect mathematical models with artificial intelligence. OpTex is the HY's artificial intelligence that makes artificial intelligences. OpTex, Optimization Expert System, is an optimization technology aimed at producing artificial hypothalamus, as the technological and logical evolution of the current decision support systems, SSDs, moved by humans, to SSDs 4.0 moved by robots.
The goal of OpTex is: the best way to make software is to haven't to do it. The HY approach is aimed to develop mathematical models using cognitive robots, that eliminates the tasks of computer programming, since the robots takes care of this process. This enhancement the mathematical modeling capacity of the professionals and produce error-free code.
Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines, of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. OpTex can produce infinite lines of perfect source code per period. OpTex are oriented to state-of-the-art decision support systems, DSS, that integrate state-of-the-art technologies of advanced analytics and optimization, like mathematical programming, advanced probabilistic, machine learning, and artificial neural nets.
OpTex generates the large-scale algorithms required by the artificial hypothalamus.
Highly complex mathematical models for end users.
HY uses OpTex to implement all its end-user mathematical modeling applications. HYPOTHALAMUS is a collection of specialized algorithms for optimize the value chain.
An example of the solutions offered is HYPOWER, a decision support system for agents in the electricity and gas sector. Another example is oil and gas artificial brain, which covers the entire oil supply chain. The solutions cover multiple economic and industrial sectors. On YouTube and LinkedIn you can obtain the videos related with mathematical models to end users, and the technical documentation about them. The new way of mathematics is directly related to the parallel thinking, and today it can be said that like paper-based math, sequential mathematics for single-processor computers, will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Thank you for your attention.